So now that we talked about correlation, we're going to talk about actual linear regression. And linear regression, also known as least squares regression, comes from the concept of a line of best fit. And the line of best fit is the line for which the sum of what we want to talk about here is what we call our residuals. It's the line for which the sum of the residuals of the squares is a minimum. And when we talk about that, what we're really talking about is this thing that we also refer to as, it's called least squares regression. Least squares regression. And what it tries to do is it tries to minimize the square value away from some mean line, some average line. And we do that by starting off by, what is a line? What's the equation of a line? Well, we know the equation of a line is y is equal to mx plus b, where m is generally what we call our slope, or it's the average rate of change. It's the average rate of change. And then the b is what we call our y-intercept. B is what we call the y-intercept. And it's the starting value of the function when it's x equals 0, when x is set to 0. So the regression equation just takes that and writes it like this. We come up with this new variable which we call y hat. And it's equal to, well, instead of using the letter m, we're going to use this b1x plus b0, where y hat, this is referred to as y hat, is the predicted or estimated y value, and b1 is the slope of the regression line, still in front of your x. This is just like y equals mx plus b, and b0 is the starting point, or your y-intercept. And so when we do our particular equations, we're going to use our calculator to find the actual linear regression, the least squares regression, or line of best fit. And so to do that, here's what we're going to do. We have the same data here. We're going to go ahead and find the least squares regression line again. To do it, you do it just like you're doing the actual correlation. So we're going to go stat, calc, number, linreg, ax plus b, L1, comma, L2. When I do that, I get a and b. So the equation is written as y equals ax plus b. Remember, we write our equation. Y hat is equal to b1 x plus b0. So we're going to replace those variables with what we know now. Y hat, well, we have ax, so that a is equal to negative 3, negative 0.39, we'll say negative 0.397x, plus, and our b here is equal to 113.323. So this is the regression, this is the equation of the regression line, or the line of best fit. And using this line, I can make predictions based off of that. If we want to, we could actually replace the variables in this particular line with the variables from the equation. Notice that this is the x variable and this is the y variable. So we can really write this as the predicted pulse rate. Our pulse rate hat is equal to negative 0.397. Our x is height, plus 113.323. So this will help us answer these next questions, which say, predict the pulse rate for a person that has a height of 73 inches. Well, look, I know that I'm looking for a person with a height of 73 inches, and I know the height variable sits here, so I want to predict their pulse rate. So that predicted pulse rate, our pulse rate hat, remember the hat means predicted, negative 0.397 times 73 inches, plus 113.323. And so when we do this, we get negative 0.397 times 13 is this, plus 113.323. And I get this value right here. And I want to see if 108, so the predicted pulse rate here, predicted pulse rate is equal to 108.162. I want to know, does that answer make sense? Well, if we come on here and look at our graph, 73 inches is a little bit more than 72 inches right here, right, at 85. And it's a little more than, and it's in between 75. So look, we get a value of 108.162. Does that answer make sense? Well, it's really hard to tell here because you have all these different values, but it's not unreal because our largest value is at 62 inches. 62 inches, they have a pulse rate of 105. So this is not an unreal answer. It says, how tall is the person with a pulse rate of 75 beats per minute? So this one says the pulse rate here. We're going to plug that in for the pulse rate, which is 75. That's equal to negative 0.397 times the height. They want to know how tall the person is, x, plus 113.323. So to solve this, I'm going to first solve for x. I'm going to subtract off 113.323 on both sides. So I do 75 minus 113.323. I get a negative 38.323 is equal to negative 0.397x. I'm going to divide everything by what's in front of x. So negative 0.397. So divide this by negative 0.397. And I get them at a height of x equal to 96.53 inches.